Okay. Yeah, that makes it a lot easier for me because I never speak about my research in German, so that should help. So I wanted to give you a little bit of background because you may not know me. I got a diploma degree in computational visualistics, computer visualistics at the University of Magdeburg. Afterwards, in 2004, I went for a PhD in computer science at the University of Calgary. And so I have not lived in Germany for about 10 years. That's why you're now spared my horrible research German. And then I did a postdoc at INRIA and later became a permanent research scientist at INRIA, which is the French National Research Institute for Computer Science. And before I went there for my postdoc, I had no idea what INRIA was, so I wanted to give you a little bit of an overview. So INRIA is most often compared to the Fraunhofer Institute in Germany. So it has 8 research centers, about 3,000 researchers overall. So and INRIA stands for the National Institute of Research in Informatics and Automation. So there's lots of researchers in computer science and mathematicians. And each of these researchers belongs to one research team. So there are about 380 teams overall. And my research center is called Saclay, which is just south of Paris. So on the map here, you can see Paris. So we're kind of in this blobby area there. And Paris is about 25 kilometers northeast. And in this research center, we have 52 teams. And this area that we're in is really interesting because at some point when Sarkozy was president, he wanted to make this sort of the Silicon Valley of France. So a lot of research institutes from companies and a lot of universities and international research centers are moving to this area. And our team is the description of the French research landscape is fairly complicated because they have all these distinctions between different types of universities and engineering schools and special engineering schools and all that. Ask me later if you're interested. I'm beginning to understand, but it's really complicated. But so we are on the campus of the University of Paris Sud, which has, in this area, there are about almost 50,000 students. My team is called AVES. And I forgot to put a picture here, but we're 4 permanent researchers, so it's a bit different than a typical professor-led lab in Germany, in that we have 4 permanent researchers, out of which there's 1 team leader, which is a bit comparable to a professor who would be leading a team in Germany. Currently we have 3 postdocs, 1 engineer. An engineer, that's something special that you have at INRIA as well, where you can hire people just to program for you. It's a bit like a Hiwi, but with a degree. So, and we have 6 PhD students and 3 interns. So my background is I'm mainly working in the area of information visualization, a little bit in visual analytics, and I was trying to merge that with computer-supported cooperative work in human-computer interaction. And this is a really interesting area these are interesting areas to combine because there's a lot of intersection between social sciences and computer science possible here. And in this talk, I want to give you a little bit of an overview of how social sciences and computer science interact in this area. My main focus is collaborative information visualization. I'm going to tell you more about what that actually is. So first of all, what is it and why would you want to do collaborative information visualization? So I'm assuming most of you know about information visualization, right? How many of you have taken a course in that before? Oh, you have some work to do. Okay. Okay. So, so information visualization, I'm glad I didn't delete this slide. So, information visualization is about, imagine you have a data set of some sort, like a huge Excel table, and you want to you don't know what's in that Excel table, and you want to make it visual. And making it visual is a goal you may have because a visual display of information can help you first, so what is called amplify cognition. That means you often can think better when you have a visual representation in front of you, and you can see, humans are really good at seeing visual patterns. And once they're interactive, visualizations are interactive, they also become very good tools for exploration in data set where you can't easily query the data. And it's all done because, yeah, as I said, we're very good at perception, visual perception. Visual perception is the channel that we have that has the highest bandwidth compared to auditory or touch, for example. Yet, when people build visualization tools, currently, this is the type of context they're supporting. Usually, it's a work context, so you're paid to do some job. You have very specific questions and tasks in this job. Usually, it's domain specific, like medical, biological, and so on. There's a single user on a single PC with a mouse and a keyboard setting. But interestingly, now a lot of new usage contexts are emerging. For one, people are starting to use all sorts of new devices where they want to look at their data. So just imagine if you're using something like Fitbit or any other personal health tracker, you may want to use that on your phone and not sit down on your PC to use it. Also, I've already seen lots of large displays here. This is another interesting environment for visualization. Then there are people beyond the work environment that now want to use visualization, like, first of all, in a social setting. So you may want to look at data with your friends or even with work colleagues if you stay in the work context. And also you may have new goals that you haven't had before, where you want to see your data all the time, you want to have it always updated, and you want to see social data that has nothing to do with your work. And this is actually a really emerging area, and there are lots and lots of new jobs, startups, and research groups being built around this area of visualization. The research question I have in this space is, how can we enable effective access to visualization in a variety of non-traditional contexts? And in this research space, I've more or less worked on 4 areas. So one is figuring out techniques that work on novel devices. So how can we build representations of data that are good for mobile, for wall display, and so on. Mostly wall displays is what I focused on. Then sometimes I've applied this to different application areas. I work a lot on evaluation. Actually, you're going to hear a lot about a lot of projects I've done in the area of evaluation today. And then I'm trying to build some theory around how people actually approach data analysis and how they work together. So as I said, my main focus is on leveraging new devices and supporting new types of audiences. In this area, collaboration is what I focus on most. So if you think about this as research areas, we have the research area of information visualization and the area of CCW that I'm trying to merge. So CCW is the research area of computer-supported cooperative work. And just as a question, has anyone here taken a course in that before? One, okay. I'm not surprised because it's actually very rarely taught in Germany. There are just maybe 2 or 3 really well-known international operating professors in Germany that work in this area and would probably have a course on this. But it is actually a really, really interesting area that really merges social sciences and computer sciences really well. And it's very visible in the papers that are published at the biggest conference. So I wanted to give you a very short introduction to CSCW before I delve into more of the details. So the problems the area was first sort of conceived by Doug Engelbart, who's you guys may know because he's the inventor of the mouse. He just recently died. Where he said in the 1950s, the world is getting more complex and problems are getting more urgent. In the 1950s he said this, I think it's even more true now. And these must be dealt with collaboratively or collectively. However, human abilities to deal collectively with complex and urgent problems are not increasing as fast as these problems. So really the goal would be, if you could do something to improve human capability to deal with these problems, then you would really contribute something basic. So here the idea is, can we somehow build things that improve humans' capabilities to collaboratively work out problems? And his vision was that I had a clear picture that one's colleagues could be sitting in other rooms with similar workstations tied to the same computer complex and could be sharing and working and collaborating very closely. There'll be new skills and so on to do that. So this was the 1950s, and he had sort of this vision of people having distributed workstations and working together on problems. And it still took about 37 years before the research area of CCW was born in 1987. And nowadays, there are two ways in which the research area is defined. So one group of definitions is about saying that CCW is about groups of users and how to design systems to support their work as a group and how to understand the technology on their work patterns. And this part on understanding the effect of technology on their work patterns, that's where social science is very, very much involved. And the other definition is more, I would say, technically centered. So here the definition is, it's the study of an electronic workplace, an organization-wide system that integrates information processing and communication activities. So this definition, the lower one, has very little about the user in it. But here you can see with these two definitions that they're actually sort of two general research directions. Here, one is about very technical, it's about groupware. So how to design software that actually supports groups well, what are the right architectures, what are the right protocols to use so people can exchange information. And then CCW, more broadly, is really about the context of groupware design. How do you design software well so it supports how people work and how they think and how they interact with each other. And there are different ways in which you can categorize the research field. And I'm just going to introduce to you one model that I find useful as a starting point. But you'll see there are some limits to this model, and people have introduced other models beyond this one, but I think this is a good starting point. So one way to think about collaboration or collaborative work is to think about the space-time matrix. So here we divide how people work according to when they work together. Either they work together at the same time, or they work together at different times, or the place where they work. So do they work in a shared space, or they work in distributed locations? So let's look at each of these quadrants in turn. So working at the same time and the same place is basically face-to-face interaction. You're sitting with somebody at the same table, you're trying to make decisions, using the same computer like a tabletop display, for example, at the same time. So here's one example research area called single display groupware. And here you really want to figure out how people use multiple input devices on the same computer. This is a picture of a really old, that's kind of not very visible, but where people are just using the same laptop and people are trying to figure out how bad is it for collaboration if they have to share buttons, for example. You have to figure out how they share input, how that works technically, but also how does it affect people's ability to work together. The next quadrant is about working at the same time, but in different places. And examples of that are if you're, for example, chatting with somebody, you're in something like a virtual world. What is the famous one called? I just forgot. The Second Life, exactly. Or you're filling out a Google Doc from different places, for example. So here, a really old area of research was, for example, figuring out how shared screens and windows work. So you had like two people on. You're trying to make sure that people sitting on different computers are actually seeing the same thing. This is also very important in visualization when you're working remotely. Like, imagine you have two doctors that are supposed to see the same X-ray of a person, and they have to make a decision together. How do you make sure they see the same thing? There are many technical concerns in this question, but there are also very interesting social questions in this area where you have to figure out how do people take turns if they can only interact one at a time? How much control can you give people, especially if they have different hierarchy levels? And how much can you show somebody private information, not the other person? Does that hinder them working together or not? Now, the third quadrant is people work in different places, but also at different times. And a very typical example that you all know is email. And of course, you can push email to be almost synchronous interaction, but usually it's asynchronous, so at different times. But also if you post to forums or if you change shifts, for example, in a factory, that would all be different. No, actually, shift changing is coming up after. But yeah, email, bulletin boards, forums, and so on, that's all examples of research in this lower right quadrant. And email is an interesting one. I have never done research on, but there are many different types of styles of email, people trying to figure out how can people manage their email better and respond to each other better, what is the best structure to show people, and so on. That is, yeah, there are technical questions in that, and the social questions would be, how do you manage information overload, how do you manage email complexity, how do people manage spam, how do they archive their information, and how does this affect how they answer and communicate with others. And the final quadrant in the space-time matrix is yeah, people working at the same place but in different times, and shift change again is one of the most common tasks in this area. So you have like team rooms that people enter at different times, large public displays that people walk by at different times, and an example, as I said, is yeah, like large control rooms, for example, where information has to move from one shift to the next, and a research question would be, how do we figure out how that affects how people work as a whole team. So the research field of CCW has many different publication venues, and here's just some of them. Very central is the conference called CCW. In Europe, there's one called ECCW, and then there's this journal of CCW. And then there are some more HCI-related conferences a bit on the outside where you can find CCW papers, but they're not, I mean, there are many others. For example, CHI is the one you may know, that is the biggest human-computer interaction conference. So as I said before, CCW is I think should be interesting to you guys because it's very interdisciplinary. So you have computer scientists there who work a lot on technical issues like what are the right protocols to use, what are the algorithms, how do you design the user interfaces for collaborative work. Then there are sociologists who look at studying work and social practices, psychologists who have to figure out what the impact on cognitive processes is, for example, of collaboration or of the interface and of the technology. And of course, there are also economists, organizational theorists, and educators, and many others involved. And the really underlying fundamental issue that people look at in CCW is based on the fact that the needs of a group are different than the needs of a single person when you're using an interface. And that this need should be reflected in the technology. But it's not always clear, or most of the time it's not clear what this changed need actually is. So people need to understand what the differences are. So the design cycle is often you figure out, you observe, you try to understand what the requirements are, then you try to support it, and you observe again if it's actually working, and so on. So are there any questions up to this part? Okay. Because now I'm going to move on. Now that you know a bit about CCW, I'm going to show you a little bit about what I've been working on in the area of collaborative information visualization. So we define collaborative information visualization based on a definition of information visualization. So in the case of collaborative visualization, this is the use of computer-supported, most of the time interactive, visual representations of data. And this is the part that's new for collaborative visualization that isn't in the original definition of visualization. By more than one person, with the goal of contributing to joint information processing activities. The original definition of visualization would say computer-supported interactive visual representation of data to amplify cognition. This is what I discussed in the beginning. to amplify cognition is something that cannot be as easily said for collaborative visualization because it's unclear what cognition is in the sense of collaboration, but maybe that's too much detail. So this is really an emerging area in the area of in visualization, and this can be seen here where we looked at the keywords people used on the papers that were published at the biggest visualization conference from 2004 to 2013. So there was actually per year, there are probably on average about 3 papers published on collaboration so far. There was a bump in 2010 where the topic became quite popular. And the reason being is that there were 2 PhD students, one was me and there was another one working on this area. Now there was, so now our PhD students have to start publishing. I think that's maybe it will go up after. And in this area there are many interesting specific research challenges. One is, and I would categorize them actually as socio-technical. So there's technical components in them and there are social components in them. So one of the things that you don't have in single user visualization is that now you have multiple people that you need to support. They have multiple backgrounds, different working styles, different preferences on what kind of representations they want to see or want to use, and how they generally want to work with computers. The tasks are no longer centered only on what would be called task work. They're not only centered on supporting a specific thing you want to accomplish, but they're also centered around enabling collaboration. So it's another component of the task work that you have to look at in collaboration. Cognition is an interesting one that's always interesting to study in the area of visualization, but once you look at collaboration, it is very unclear how people actually make sense of something in a team. It's already hard to study that for a single person, but it's even harder to figure out how a team makes sense of data. When you look at just sort of the analysis results, it's you have to make sure that people are able to build consensus and that they can share the things they found. And I'll show you a project later where this worked and didn't work based on how people work together. When you evaluate a visualization system, you now no longer need to look at only the fact that the system supports the task well, the general task, but you also need to evaluate whether it supports the teamwork well. So that makes it more complicated. A more technical thing is interaction. How do you support multiple parallel inputs, people using novel display devices and so on? And how do you build visual representations for multiple displays, for novel displays, and that work well with certain input technology? And here's some example things that people have studied that were a little bit more socio-technical in nature. So here, this is an interesting project by Anthony Robinson that was published a few years ago where he was giving 2 types of people the same task to do and then asked them to meet and discuss what kind of results they wanted to communicate. And he was studying how people used the space that they had to put their artifacts. It was a problem-solving task where they had to solve a mystery puzzle, more or less. So he was trying to figure out how the space was used in order to later be able to build a digital system that would support this task for teamwork. This was an interesting paper by Anderson North, where they were trying to figure out what effect does it have if you have a huge display space such as this one on a very similar problem-solving task if you let people physically move the artifacts they have and arrange the documents in the space according to their thoughts. And if you compare that to a case where they couldn't do that. And it turns out it's very, very important. And another project where people were looking at what is the role of note-taking around a big tabletop display when people had to do a digital task with the goal to later figure out would it make sense to support note-taking on a tabletop display, or is it something that people would better do outside? Is this something that should be built into the system or not? So some general research questions people are asking in this space is trying to figure out how people conduct face-to-face analysis, So if they analyze data from visual representations as a team, how do they do it? Does this affect how we need to design visualizations? We know a lot about how to design visualizations for single users, but do we need to change something about that when we move to more than one person? And if we assume that collaboration is useful for some tasks, but not for all of them, what are the tasks and what are the data sets that it's most useful for? So the goal really is, we know a lot about single-user visualizations for desktop, for mouse and keyboard settings, but we want to support people working probably in other environments as a team, what needs to change. And I'm going to show you 3 research projects that I've done in that space that had a more social component to it. There were a couple more, but well, I thought for this audience these ones would be the most interesting. So this one I worked on while I was doing an internship at Microsoft with Daniel Fisher, and we were trying to figure out how could we support people who have to do a very focused task in being aware of what the other person was doing. So our hypothesis was we take a digital tabletop display as this one. This was the Microsoft Surface One, very small, it's about a 30-inch display. And we gave people a task where they had documents to read. And our hypothesis was that even though they're sharing the same screen and they're working in the same space, they may not always know what the other person is doing. And awareness is a key component of collaboration, because it really helps you to coordinate and to communicate with the other person if you know what the other person is actually doing. So the task that we gave people comes from the VAST 2006 contest, and it's a data set about 200, it contains 200 documents, and people have to solve a mystery that is more or less explained in this graph. There are people there are places, there are institutions, and they're somehow connected by a plot where there's something illegal going on, and the participants we had in our, well, later the participants, the people using our tool, had to figure out what was going on. And I'll just show you a video of what the system looked like. Oh, so I'm just gonna show you. Yeah, it's a bit bright. So we have the tabletop display here, where the goal is that you're sitting there with another person and you can discuss you can search and you can discuss the documents that you're reading. So you can start your work by searching for a specific word, in this case BSE. There was some document saying there's some mystery about BSE, and then you get a visual representation of the search term, how many times the search word occurs, and once you type another search, a new little representation, spatial representation appears, and when you open it, now you see that there are 5 documents, the gray rectangles, and the colors, the stripes indicate which other search terms were found in these documents. So the first one contained 3, and the next contain 1 other search term, and the last 2 contain only the search term. And there are some gray bars you can see here that just show you how many times the search term occurred. And then you can browse the documents by just putting your finger on them, and you get some detail on demand, like what date it was from, the title, the sentences extracted that contain the search term. And if you're interested in one of them, you can just pull it out, and then you get a little representation of the document that you can open, and then you can start reading it. And again, in the document reader, you can see who opened the document. That's a little icon, and the words show up. And then the background and the document representation changes to gray, meaning this document has actually been read before. So now you can browse this, and if there's something in the document that you find interesting, you can, well, this will be shown next. You can highlight the word, and then you can keep on searching. So I think this is what's happening here. And of course, you're free to minimize the documents and share them with the other person. So here I'm interested in this person here, and I can just search for a word, and a new search is generated. And as soon as I do that, all the open documents are tagged to see if the search term actually also occurs in any of the others. So here, this is one awareness feature that gives you the hint that, okay, it's only the first document here that actually has all search terms included. The real awareness features are starting as soon as the other person on the other side of the table is starting to search. So here this person is the blue person, and all searches by this person are tagged in blue, but the stripes also appear on the document from the blue person in blue. So this can give you a hint that on the top there's actually two searches, two red searches, and in the middle is a blue document that doesn't have this term, so maybe something interesting happened there. So the person can use the information from the partner to be actually pointed to some documents of potential interest. So that's the main idea between that system. And what we term this awareness feature is collaborative brushing and linking. And brushing and linking is an interaction technique in the visualization area, often used on scatter plot matrices like here, where the red x's are data points on just an XY plot. And if you highlight some of them, they turn red, but they turn red in all of the other ones. The same data points turn red. But in our case, we extended this to the collaborative case, where if one person makes an action, it is always shown in the data that the other person is seeing. So the awareness information we're trying to show with that technique was, did another search also find my document as my own? Has somebody else issued the same search? Has someone extracted the same information? And has somebody read the same document or not? And here's again a picture of the visual representation and how this is encoded there. And the focus of adding these annotations is that you can focus on your own action, but you can also at a glance get an overview of the group activities. And there's this notion of an information scent, which comes from information foraging theory, where you are led towards information by triggers of some sort, in this case visual triggers. So the idea was that this may lead to better coverage and less missed facts, and may lead to better validation. There were some limitations of the tool, like the surface at the time was really too small, reading text was a bit difficult, the seating arrangement wasn't very comfortable, but these are all technical limitations that can be solved with better technology. Next, we wanted to find out in a follow-up project whether or not these awareness features were helpful, or whether the tool actually, how well the tool would work in collaboration. So really the study goal was, we're trying to understand the digital tabletop as a data analysis environment where people have to actually seriously work on a task. At the time when we were doing this project, actually a lot of tabletop displays were showing picture sorting tasks or games, or more toy examples of tasks. And we were really trying to give people a more serious task to work on in collaboration. So we wanted to see how people coordinate their tasks, how they collaborate, and whether we needed to change the design based on how people worked with the tool. So we had 15 pairs of participants. We recruited them that they had to know each other. It's a very common thing. They had to have at least a master's or advanced degree, because it was a more complicated task to do. And they had to identify as enjoying puzzles and mysteries. And we collected a lot of data and worked for weeks and weeks on analyzing it. A lot of video coding and log file analysis and so on went into it. And what we used is this data set I described to you before, this last 2006 challenge data set where we had 246 documents. And the task started by people getting a document that said, okay, somebody was driving their car into a bank and was yelling, "Flowers, flowers, I smell the flowers." So this is what the document said, and then people had to go on and figure out why this happened, why flowers, where the flowers coming from, and what is going on. This was happening in the city of Alderwood. People had to figure out there was an E. coli contamination happening in the city, so there's something going on. There were poisoned apples, so another piece of the puzzle, and this was in the end led to a terrorism organization in South America. So when we looked at how people actually solved the task, it was very interesting to see that already from reading the starting document about this guy driving into a bank, people started very differently. So about 9 out of the 15 groups started with very close collaboration. So they looked at the document together, and then they decided to search for the same things, like, okay, let's search for all the banks, let's search for people in the hospital, and so on. Whereas 6 groups started very loose collaboration, where one person said, I'm going to look at the map and see if there's anything suspicious here, and the other person maybe started to look at hospitals. So they were starting to search for completely different things. And this is a picture that we found throughout the analysis of this data, is that people adopted really, really, really different collaboration styles. And this also influenced at what data and views they were sharing and using. And it also allowed, basically how they collaborated, allowed or didn't allow flexible investigation. So what we came up with is a set of 10 different collaboration styles that people adopted, and I'm going to step through them a little bit. They range from what we consider very close collaboration. On the far left is people discussing, for example, to very loose collaboration that happened very rarely, but at some point, one participant or two were just completely disengaged and had to take a break, and only one person was working. So, so a very close collaboration style was characterized by very limited interaction with the system. So people were mostly speaking, they were discussing, they maybe had one shared document open, but they were talking about just that. Now, a little bit less closely collaborative was when they decided to read the same document, but they were silent. So there wasn't really information exchange, but people were aware that they were reading the same thing. So this may have been done on one document or on the same document duplicated. Sometimes, then even moving a little bit more towards loose collaboration, they decided they would work on the same problem. For example, they found that there were some kids that were getting sick. So they decided, okay, we're going to look for all the documents that contain sick children, and I'm going to read one and you'll read the other. But at least people knew they were working on the same problem. And otherwise, people were starting to work on the same general problem, like poisoning, for example. Then one person was looking for sick children, the other was looking for an incident in the harbor or something like that. And then comes the loose collaboration where they're working on completely different things, or one person wasn't working. And interestingly, you can take all these 10 different collaboration styles and you can color them. And we decided to color the loose collaboration ones, the last 3 as blue and the other ones yellow. And now if we look at the temporal distribution of how people work together, we can see considerably different collaboration styles emerge. Where, for example, group 2, they worked almost all the time very closely together. They were almost always reading the same document together. Whereas group 5, basically from the start decided they were not doing that. They would divide and conquer. You solve the problem, I solve the problem. Whoever has the best solution, that's what we'll take. And if you look at the whole spread across all groups that we tested, there was a huge spread in how much people collaborated closely together. So the highest amount was 92% of the time, and the lowest was 32% of the time. And this is interesting, especially if we compare it to how successfully people solve the task. So we found that the groups that were loosely collaborating, the blue ones here, they actually did very poorly. So this debriefing score on the x-axis tells how successful, the higher the score, the more successfully they solved the task. So the 4 most closely collaborating teams had the highest scores, And except for this one outlier there, the four groups here, the loosely collaborating ones, were not very successful. So what does that tell us about the tool that we build or the tabletop in general for data analysis? So in our case, the pros that we had or that we saw of the tabletop display was people had a shared context. When they had time, they could share, discuss, and be aware of what each other were doing. So one of the people said, sometimes my partner and I fight about who gets to use the computer, so it was nice to share that. One person standing and another sitting, that's never a collaborative act, and here we're assembling a whole thing together. And our design also supported, I mean, we could see these different types of collaboration styles because the system somehow supported it. So this could be seen as a good or a bad thing. I'll get to that in a minute. People were able to switch from closely to loosely collaborating fairly easily. And what was really interesting is that people really approached the tabletop software very naturally. So people weren't afraid of using it. And this is something I have experienced quite differently in other user studies. Especially here we had some older participants who sometimes like, oh, I don't want to break things, and they're very scared of want to, practice before they start the real thing. But here this wasn't the case. So the technical starting barriers were really low. So the negative part was that not all collaboration strategies were successful. So people who didn't collaborate closely weren't very successful. So the question would be, do we force people to be more closely collaborated or not? What maybe should we have or shouldn't we have? That's an interesting question. And the form factor still wasn't very good. And we could have added more support for changing analysis phases when they move from information foraging to hypothesis generation or so. That a few added tools would have been good. And one thing that in computer science you always need to have is implications for design. When you do these kinds of a little bit more social studies, you need to explain how they make sense for building your tools, or in general how they can be useful for others building these kinds of tools. So what we found here is that it's very important to design for transient behavior. So people behave very differently in collaboration, and they even if they choose one thing, they may want to change, and it's important to support that. And it would be good to encourage closely coupled work because we saw that being the most successful. So maybe these little awareness features we had there weren't enough. The people who didn't work closely together, they didn't even see it because they never had any search term that overlapped, for example. So there was nothing there for them to see. So maybe we could have come up with something that would have helped them to be more closely coupled. So how much time do I have left? That's okay. So in conclusion, the tabletop setting was quite a successful work environment, actually. Most teams were quite successful. People enjoyed doing the task together. It supported a variety of strategies, and I'm one of these people who like to design technology that allows people to be as free and unconstrained as possible, so I think that's a positive step. And we found that closely coupled collaboration was very important, and the next step would be to figure out how to support that better. So one of the next things we're currently working on in my research team is that we're trying to figure out we're trying to work with the fact that currently most data analysis works in isolated tools by individuals. And it makes a lot of sense. A lot of people are doing analysis in Excel, in R, SPSS, and many other tools that help them to look at their data. But almost always they have to do some sort of synthesis for other people. So in notes, in emails, in presentations, in meetings, and so on. So the question is really, how can we bridge this gap between people who are doing individual work and they have to move to collaboration? So far there has been a lot of research in the left box and in the right box, but people haven't looked very much in how to move between them. So this is the last project I'm going to show. One of the projects that we just published last year was on this large high-resolution display ball that we have in my research team. So this this wall is made up of 8x4, 32-inch cinema Apple Cinema LCD displays. And they're situated in this room called the Wild Room, where you can have people at, Wild stands for something large displays. I don't remember. It has a very good acronym. We're building a second wall that is bigger, that's called Wilder. So the wild environment is, you can see in this picture here, where we actually have tabletop displays. And what's important about this picture is that we often have, and when we have these large displays, people standing at different distances from the display. So the question would be really, who do we optimize the display for? Because if you want to support the guy sitting in the far back seeing the display, you need to display everything big. If you want to support the people standing up front, you can have a lot of detailed information the guy at the back wouldn't see. So the question that we had is, can we bridge the gap of people working individually and working together while they're in the same space and at the same time, and they're looking at the data visualizations at the same time. So here, if we take individual work, let's say we have the wall and it's hard to see, it's a little weather visualization where we have one person looking at detailed data and another person who wants to see more global data, like an overview, for example. Let's say the left person is looking at daily weather data and she's looking at monthly aggregated weather data. How can we more easily help them move to collaborative work phase? So what we built is called hybrid images. And here's the first visualization that's part of this project. So here we have daily temperature data, or monthly temperature data for several years, over several months. And this is a simulation of our wild display. So we're standing very close to the display now, about 50 centimeters. And now we're moving away from the wall until we see everything. So what you can see when you're standing far away, you actually don't see very much. So this visualization is really optimized for people standing close who want to see a whole lot of information. Now we can do the other thing is we can display the yearly aggregates, or the aggregates over all the years that we have per month for each of these cities. So now we're standing far away and we can see the aggregates fairly well, but the problem is when we move close, the view becomes less and less useful because we're cropping away a lot of the data and moving into detail that is no longer as useful to see. There's no need to really move that close. There are many, many other viewpoints where you can see that information, and you can see more of the information well. So what do we do if we want to display these two visualizations? There are two main merging options. One is you can use a split screen. You display one on the left and one on the right, but the problem is you're losing half of your display space. So you can display less data. And the other option is blending. So you somehow find a clever way of displaying them both in the same space so that they're both readable. And that's exactly what we try to do. So the blending approach is what we took. So the naive approach to blending is you just take the two visualizations and you alpha blend them. And the result would be looking like this, where now we're far away, but I'd like you to look at the numbers here. So now you're moving close, you see the detail, but the sharp edges of the numbers and of the bar charts here, they actually hinder you reading the detailed information. They're quite distracting to read them. So the naive approach is not the most successful. So what we used is a technique that has been developed in perceptual science. It's called hybrid images, that takes advantage of the approach, of the fact that humans crop certain parts of the information or certain frequencies from the image space when you're looking at more global and more local stuff. So when we high and low pass filter the two images that before we're blending them, the result looks like this, where we're moving close. Again, look at the numbers there in the background. You can see the detail really well, but the bigger numbers you see from far away, they more or less disappear. They no longer hinder you reading the detailed information, and the detailed information is also not distracting when you're standing far away. It's a very, very simple idea that works well for showing two images at the same resolution. So the outcome of this project is there's a paper if you would like to read more about that. We're working on releasing the software very soon where you can load in two images and you can work with them and display them on whichever wall size and resolution of your wall you want. And currently I'm working with a master's student on a user study to figure out the more social side of this. How does it affect people working together when they have to move through the room back and forth to actually see different parts of the information? So this is something, we're really interested in understanding. So what are the collaboration style that this type of representation affords, and how are people using the near and the far image during collaboration? There are a couple other future projects we're working on. We're going to work on in my particular subgroup is note-taking is one where people do a lot of individual note-taking, but they often share their notes. So we're trying to figure out how people transition from note-taking by themselves to sharing notes with the group. And this is in the context of a digital humanities project called Sendary that it's a European Union shared project. And also a bit more on the technical side, I'm trying to understand what gestures and interaction techniques work well in collaboration, and how do different gestures affect collaboration styles. So with that, my 1 hour. And so just in general, 2 plugs. If you're interested in working on any of these projects, we are always, every year, looking for and taking interns. This can be master's projects, bachelor projects. We also often have PhD students coming to visit for 1, 2, or 3 months. If this is planned far enough in advance, there's also sometimes funding for that. We often have visiting researchers in our lab as well. And if you're interested in visualization as a research area in general, next year we will have the largest international conference in Paris. This year. This is so much work to organize, it feels like it's like you're away. And my team leader, Jean-Daniel Fiquet, he's the general chair, so we're very involved in organizing that, but it will be the best ever. And that's the end of my talk, and I'm happy to take any questions you have in German or English or French if necessary.